The previous sessions we have discussed declaring one class inside another class. So say if we have class 1 and we are declaring the class 2 handle inside the class 1 handle, and we are using that properties of class 1. And today we are going to start with a concept called inheritance. So basically, in case of inheritance, we are going to have two types of classes. One is called parent class, and another is called child class. So basically, the properties or the methods which are declared inside the parent class can be accessed by the child class. So the child class is basically a derived class of parent class, whereas the properties or the methods which are declared inside the child class cannot be accessed by my parent class. So my child class can access all the properties and methods which are present inside my parent class, whereas my parent class cannot access the properties or methods which are present inside my child class. So this is the first rule of inheritance. So this is the first and basic rule of inheritance. So let us see an example of this inheritance. So if I have a class called parent underscore class, and inside this class, say and I'm ending this class. So this is a property which I have in my parent class. I will add one more variable, say int m. So this is my property, and if I want to create a child class which is derived from my parent class, then I will use the syntax. So the child class name child underscore class extends. So I should use the keyword extends. So this is a keyword which I am going to use to create a child class from my parent class. This is parent underscore class, and I'm going to declare one more property in my child class called n, and ending the class. So what happens? My parent underscore class and child underscore class. So there are two classes formed, and this child class is derived from my parent class. So the properties or the methods which are declared inside this parent class can be accessed by this child class and can be modified by this child class. But the properties or methods which are declared inside this child class are not accessed by this parent class, and they cannot be modified by this parent class also. For example, within an initial beginning block, what we'll do, we'll create handle for my child class, say child underscore class, ccl, and I will use ccl is equal to new. So with this CCL, I can access the property which is declared inside my parent class, since it is extended from my parent class. The child class is extended from my parent class. So the handle which is created for this child class with the handle which we have created for this child class, with that handle we can access this variable. So CCL dot a is equal to, we can modify that value of a also. If we have declared a is equal to, say, some 8 tick binary or hexa 5, then we can modify this value as 8 tick hexa 6. So with the help of this child class handle, since the child class is derived from the parent class, so that's why we can able to access the parent class property, and we can able to modify the parent class property. So this is the inheritance concept. And If we try to create the parent class handle like this, parent underscore class, say PC, and if we try to access the child class property, say PC dot in child class we have n, PC dot n is equal to, so say the value of n is equal to 5, then PC dot n is equal to 10. If we try to modify the value of n, then we will get a compilation error saying that parent class cannot access the child class properties. So this is the concept of inheritance. Is this clear? The concept of inheritance. This is very very important concept. Is this clear? So if you're having any doubt, you can ask. Let's discuss the super keyword. So basically, if we have two classes, one is parent class and another is child class. So inside this child class, since this child class is already derived from the parent class, and if we want to refer to any variable or property which is declared inside this parent class, say any property is declared inside this parent class, and if we want to refer this property which is declared inside the parent class from this child class, we will use the keyword super. So super basically refers to the parent class. So if we use this keyword super, so this super will refer directly to the parent class. So for example, let's take an example here. Say class test underscore one int a is equal to 0, ending the class. And class, if we want another class to be extended from this parent class, we will use test underscore 2 extends test underscore 1, and inside this class I'm going to allocate two variables, int b is equal to 1 and int c. So I'm writing a function int sum, and inside this I'm going to return c is equal to, sorry, return c plus, sorry, return b plus super dot a. So this super dot a is nothing but the property which is declared inside my parent class. So this is referring to the property which is declared inside my parent class. So if we want to refer any property which is declared inside our parent class from the child class, then we can use the keyword called super. So if you find any keyword super, then it is nothing but the property which is declared inside my parent class. And we can also use this with methods also. For example, in class test underscore 1, I have a function called void display underscore 1. I'm just displaying some random value or something I'm displaying here, and ending this function and class. And if I declare another class called class test underscore 2 extends test underscore 1, and inside this what I'm going to do is I'm calling the function super dot display underscore 1. So what happens, it will refer to the function which is declared inside my parent class, that is test underscore 1, and the statement which is declared inside this display statement will be executed. So like this, my I can create, I can extend my child class from a parent class. Is this clear?
Can you repeat again?
Yeah. So in class test underscore one, what I have done is I have written a function, void function called display underscore one, and I am displaying something. And I have created a child class called test underscore two, which is extending from test underscore one. And I am calling the function which is declared inside my test underscore one with the help of the keyword super. So if I use the keyword super with my function, then it is referring to the function which is declared inside my test underscore one. So that function will be display. So that function will be called and the statement will be displayed, which is written inside display underscore one function. That is a procedure. Is this clear?
Yes, thank you.
Yeah. So this is a way of creating child classes from parent classes. So basically, polymorphism is nothing but many forms. So polymorphism in system Verrilog provides an ability to an object to take uh, on many forms. So basically, in case of polymorphism, with the help of polymorphism, a object can act as parent class handle. So so an object can simultaneously act as a parent class type and as a child class type. So we'll see what is this meaning. So basically, with the help of polymorphism, an object can be basically it can take two forms. It can act as a parent class type and it can also act as a child class type. So with the help of polymorphism, we can achieve this. So we will see one basic example. So we'll see a concept called overriding methods. So first of all, the basic rule in OOP is any extended class object or any child class can be assigned to base class handle, but vice versa is not possible. So any child class handle can be assigned to base class handle, but a base class handle cannot be assigned to child class handle. So if we have a child class, so if we have a parent class and the parent class handle is PC, and if we have a child class, say child underscore class, and for this the handle is ch, so c PC can point to a child class. So a child class can be assigned to a parent class, but vice versa is not possible. So this is the rule of OOP. So this is a basic rule of OOP. So this we have to remember. So let us see an example here. So say class parent underscore class, and in this parent underscore class, if we have declared a integer called, or if we declared a task called tk underscore 1, and I'm declaring some logic in this task and ending the task and ending the class. And if I have another class called child underscore class, and in this class I'm declaring another task called tk underscore 2. So in this task I'm declaring some logic and ending the task. So within an initial beginning block, wait a minute, I'm creating the handle of my parent class as parent underscore class PC and child underscore class ch. So PC can point to ch. So child class handle can be assigned to parent class. This is correct. And vice versa, that is child class handle cannot be assigned to parent class handle. This is wrong. So remember this assignment is not correct. So we will get a compilation error that child class handle cannot be assigned to, sorry, parent class handle cannot be assigned to child class handle. So the first is valid. So PC is equal to ch. And if we are trying to call the task which is present in, so I will take the task name in parent class and child class as tk underscore 1 only. And if I'm trying to call, so here only I will write it. So parent class handle is PC and child class handle is equal to ch. I am assigning child class handle to parent class handle. And if I try to call PC dot tk underscore 1, so I am calling the tk underscore 1 task with my parent class handle. So what I will expect, so I will think that the task which is present, so the logic which is present inside my child class task will be executed. So what I will think is, when I call the task which is present inside my so if I call my task with my parent handle PC, so PC.tk underscore 1, what I will think is the task which is present inside my child class will be executed. So because I assigned my parent class to child class, so sorry, because I have assigned my child class to parent class, that is parent class is pointing to a child class. So what I will think, if I call the task tk underscore 1 with my parent class, then the task which is present inside my child class will be executed. This is what I am going to think, but this will not happen. So the task which is present inside my parent class only will be executed. Since I Instead, I'm pointing my parent class to my child class, but and I'm calling my task with my parent class handle, but my task which is present inside my child class is not getting called. Instead, my parent class task is only being called. So this is what happening. So this is a very very important point. So this is the point we will be trapped in many of the cases in interviews. So this is the point which we have to remember. So what is the reason for this? So it is nothing but during the compile. So this is happening because during the compile time checking. So this is the reason. So we will discuss what is compile time checking and how it is affecting our case. So compile time checking in system Verrilog, compile time checking is a process performed by the compiler during the compilation phase to ensure type compatibility between the variables, expression, and function calls. It helps catching potential errors easily on before simulation, leading to more reliable code. So in system Verrilog, during the compile time, the simulator will check the type of the variable, expression, and function calls, the compatibility of the function calls. For example, in case of variable declarations, the compiler verifies that the declared type of a variable, example logic reg int, matches the type of the value assigned to it. For example, if we have declared a variable as logic a, so it will check. So if we try to assign a is equal to 0, or a is equal to 1, or a is equal to unknown, or a is equal to z, so these are the compatible types. So the variable a is of logic data type, so these are the compatible data types. Logic a can assign from 0 to 1, x and z. So these are all the compatible types. So if we try to declare bit a, and if we try to assign a is equal to unknown, then it is not compatible. So the compiler will give us an error. Since since the bit can take only two possible values, that is 0 and 1, so this is not compatible. So this is the compile time checking. So in the compile time checking, the compiler will check the declared type of the variable matches the type of the value assigned to it, and it also checks the expression compatibility. So it ensures that the operands in the expressions have compatible types. For example, adding two logic variables is allowed, but adding a logic variable to an integer variable is not. So we cannot add a logic variable and integer variable. So it is an expression compatibility checking. And function calls, the compiler checks that argument passed to a function matches the type expected by the function parameters, which mismatched types will result in errors. So if we have, say, a function, and a function is expecting arguments of int type, but we are passing another data type to this argument, then it is a compatible issue. So our compiler will give us an error. So this is compile time checking. So how it is affecting this assignment, sorry, so how this is affecting this function calls, you will see here. So here in this case, let's say this is not BC, this is parent class handle, and this is child class handle. So type declaration of PC. So when we declare PC as a parent class handle, the compiler remembers this type throughout the code. So what is happening is we are declaring our parent class handle as PC. So PC will be remembered as a parent class handle throughout the compile time. And assignment ch, sorry, PC is equal to ch. We are assigning PC is equal to ch in the next step. So ch is nothing but child class handle. During this assignment, the compile time checking comes into effect. So the compiler only considers the declared type of PC, parent class, and allows the assignment because a child class object is inherently compatible with its parent class. It doesn't perform any checks on the actual object type child class at this stage. So if we are assigning PC is equal to ch, this assignment will be valid by the compile time checking because this child class is derived from parent class. So this child class is derived from parent class only. So this assignment is valid because this child class is already, this child class handle ch is derived. So this child class is derived from parent class. So this assignment is valid during the compile time checking since this is derived from parent class. So this assignment will be valid. But what is happening? Calling the pc dot method. So what we are expecting, since we are having two tasks in the parent class, say this is class parent underscore class, and here we are having one task called t1, and we are having some logic end task and ending the class. I'm writing the logic once again, and we are having class child underscore class and same name task t1 and logic and ending the task and class. So we are having two handles. We are making the assignment and we are calling the task with the handle PC, parent class only, PC dot T1. So what we are expecting, since the assignment is happening, PC is pointing to CH. So the task which is declared inside my child class will be executed. But it is not happening because during the compile time checking enforces time compatibility. During assignment, PC is equal to ch, but it doesn't change the type of PC to child class. The compiler makes decision based on the declared type of the handle at a compile time, not the actual object type. Since PC is pointing to ch, we are making assignment ch is equal to PC. PC is pointing to ch, but the compiler will actually think that PC is of parent class handle only. Since we are making PC is equal to ch, but the compiler will thinks that PC is of parent class handle type only. So that's why when we are calling pc.t1, we will get only the task which is declared inside this parent class. So that's why here we are not able to achieve polymorphism. We are not able to achieve polymorphism. The parent class handle is not able to act as child class handle, since instead we are despite of trying to assign a parent class handle to a child class handle, but the compiler is not allowing us. It is only calling the task which is declared inside the parent class. So here we cannot achieve polymorphism. So to achieve polymorphism, we should use the keyword virtual. We should use the keyword virtual. So with the help of virtual keyword, we can achieve the concept of polymorphism. So with this we can achieve the polymorphism. So let's see how we are going to achieve the polymorphism. So I'm taking the same example, class parent underscore class, and in this I'm having it. So I should use keyword virtual within my parent class task, virtual task t1, writing some logic and task and ending the class. And I'm declaring one derived class, class child underscore class extends parent underscore class. In this, I'm declaring the same task, task t1, and ending the task and ending the class. So in previous example also, I should take child class extends from parent class, extends parent underscore class. So here, what I'm going to do, I will declare parent class handle as PC, parent underscore class as PC, and child underscore class as ch. So child underscore class as ch. Now I'm making the assignment PC is equal to ch, and I'm going to call the task PC dot, the task name is t1. So here what will happen, since I've declared the keyword virtual within my parent class with the task, so I'm making the assignment PC is equal to ch, then the compiler will call the task which is declared inside my child underscore class. Since I'm making the assignment, so with the help of virtual keyword, my I can achieve polymorphism in this case. So the task which is declared inside my child class will be executed. With the help of parent class handle, I can achieve it. So this is how the virtual keyword helps me to achieve the polymorphism. So this is about the polymorphism in